of all, we need to establish the design scope, like what are the requirements and um, functional and non-functionally, right? So, uh, okay. So yes, so here like there is a conversation which is going on between the candidate, like whether it is a mobile app or is it a device app. So like what is the like the questions which you need to ask, right? What are the questions? So what is the device, right? First question. We can write it down like any question you are thinking of. We can think about it as well. Maybe you can also write if you are able to. So mobile or web app, right? So this is the first question. Second question is when you are designing a system like Google Drive, then uh, what features what features you need, right? What features you need. So I mean, with features, I mean whether it is a upload service, download service, or I mean what are the APIs that are required. Uh, then third question, any other question you guys are able to think?
Storage limits.
Yeah, storage limits, like exactly like storage limits, but before the limits, I mean, what would be uh, the storage things, right? What you want to store, what
The
you
types of files.
want to store, whether
Mm.
it's a video or photograph or files, something like that. So
Okay,
that yeah.
type of files.
Then storage limits is a good thing, like how much storage, like how much storage, or maybe something like uh, how long you have to store the data.
Length of storage.
Yeah. So these are some questions. Anything else?
Backup of the drive, like data that we have.
Backup, yeah, backup also. Like basically, any weird questions which you can think while you are designing, we should ask the interviewer, right? With respect to designing a Google Drive or
Storage per user.
storage service. Sorry, come again.
Um, like the payment plan for the storage for each customer.
Yeah, maybe something like a subscription, right? Subscription,
Yes.
right? So these are some questions I can think maybe. Yeah, so with these questions, whatever the interviewer is like saying, we can then from this we can come back and say that these are our functional and non-functional requirements.
Mm.
And let me shrink this. So then there would be certain functional and non-functional requirement, which we will see in the context of the book for now. But yeah, just to keep the discussion engaging, and I just wanted to write it down. So let's move on. So important features would be downloading, uploading, file sync, and notifications. So obviously, when you're uploading, you have to notify the user also. So maybe there would be one notifications. Okay, so one of the functional requirements would be upload, download, and notifications. So right, and another thing would be it's a mobile app or web app, so we are allowing all the devices. So
Mm.
multiple devices are allowed. User is able to access and download stuff from multiple devices. Makes sense. Then another thing would be file size limit. So it's saying 10 GB or smaller. So this is for, and obviously you the storage is encrypted. I'm not sure like why they have written is encrypted. Is it actually encrypted or not? Uh, but yeah, because I'm just thinking key, let's say if we are sharing those files, right, we are able to share it with multiple people, the same file, then is it really encrypted? I mean the photos and all.
Yes, it should be encrypted for the security purpose. So if I share it with someone, that person at the client side, it will be downloaded and then it will be decrypted. Then only he can see the text or video, whatever it is. But in
Okay,
the storage, it will always be in encrypted form.
okay, so let's write
So
whether it is in, yeah, sorry.
access, I mean, these storages are for each individual, right? So only when you provide an access, who can access the files,
Hmm.
only then I think like some secure link needs to be provided to the user that you want to give it to,
Yeah.
Yes, that is also one kind of security we should have.
Hmm.
like a shareable link, which is
Access to
only
file.
yeah, yeah.
Okay, then there is 10 GB of storage we need, and it also mentions about
So
like
10 GB is the max limit of any file.
yeah.
Like you cannot store a single file that is more than 10 GB.
Yeah, and also I feel like they are also saying that there are 10 million users, right? If I'm not wrong, yeah, 10 million daily active users who might be using your service. Uh, okay, so yeah, 10 million I should say.
Access,
Sorry.
um, file permissions.
Yeah, file permissions is something uh, which by permissions, what do you mean by permissions? I mean,
Like this is, for example, if I want to share a file, to like we are a group of 10 people, I don't want to share it for 10 people. Though the folder is accessible, but I want to share it to one person, and like a particular file permission, like he's only able to view only that file. Like actually that.
Yeah,
Oh,
so let's exclude that from our design scope for now, maybe because we are thinking about a cloud storage. Like, and here, like the main concern is how would you store such huge data, right? For 10 million
okay.
active users, and let's say one user does at least in a day it uploads let's say 1 GB of data, something like that. So
Okay.
if there are 10 million users, then it would be something about how is 1 million? 1 million is, I think, let me just think. 1 GB and uh, 10 KB, then we have MB. Okay, so MB multiplied by 10 would be your TB, and TB, yes, so it would be essentially uh, right, 1 GB multiplied by 1 TB. That is what I'm thinking, which should be around how much this is. How much is GB 10 raised power uh, 6, right? I'm just forgetting.
Yes,
Anyways, sorry.
gigabytes.
Yeah. So let me just write it down, this thing. So what is 1 KB? So 1 KB is 10 raised power 3, right? And then you have MB, that is 10 raised power 6. Then you have GB, it is 10 raised to the power 9, right? And then one TB, which is 10 raised power 12, and 1 petabytes, right? So it is 10 raised power 15. So here what we have is GB multiplied. So yeah, we are multiplying, basically one user uploads 1 GB of file, and there are 10 million users. So how much storage we need per day? That is I'm trying to calculate. So
Uh,
which 1
So it is
million,
10 petabytes,
sorry,
10 PB. So it is 10 PB now.
10 PB. Okay, that is fine. So it is just like we are just trying to calculate like how much storage, what is the scale of the system we are looking at. That is fine. Let's move on. So here the user should be able to add the file using drag and drop, download the file, sync across multiple devices. This also looks fine. Then share your files. So this is also an important feature. So let's write it down, share files. So, okay, notification we already wrote, I guess. Yeah, we already wrote that. So features not discussed are editing and collaboration with any new document you are creating. So how does Google Doc works? You create a new document and it automatically gets saved into your drive, right? So,
mm,
and people can collaborate on that in real time, and the storage will also get updated in that case. So that makes sense. So other non-functional requirements is reliable. It should be storage, no data loss, right? This is important.
mm,
And
speed.
so, but that is what you meant, right? Backup, storing the backup. So, backup is important. If we have a backup, then it makes it more reliable, and there will be no data loss. So that is
So,
non
what is the difference in storage and backup? Drive itself is a kind of a storage and backup, isn't it?
drive itself is a storage and backup. Yeah, by backup they mean like how when you're storing the data, you will store it somewhere, right? And you should have a copy of that data. If let's say one of the server is down and you are trying to view the document, um, but
Okay, okay.
it is
So storage is the service that it is providing, but backup means it is fault tolerant. So in case of
Yeah,
if that node goes down, there is some other backup we have. So our data durability and is guaranteed.
yeah, because we use multiple, we replicate the same thing in multiple servers, right?
Right.
So I think that is,
So that is the non-functional requirement here. That
mm,
data durability should be there.
it should be a fast system. Then bandwidth, network bandwidth, user will be unhappy if they are on a mobile data plan, and high traffic volumes is expected as there are 10 million users. Then some servers offline or loads. Then they are doing some calculation. We already did it, so let's no ignore this. And so they are assuming one file and average file is 500 KB, so at least 2 MB. That is practically actually not possible. Even nowadays, if you take a photograph, right, it's more than an MB. So I don't think so. This makes sense. But yeah, uh, it is 1:1 read to write ratio. This is important, I think, because here now we cannot say it's a read heavy system or a write heavy system. So it is 1:1 read or write. So uh, your system should be optimal for both the use cases. So for example, so how do I think is like if you are designing a system, so it should be optimal for the read and optimal for the write. So I believe the data sources for read and write should be different. Uh, it should not be same. Uh, what do you guys think? Like, I mean,
So it depends on the total read and write volume. If the volume is very heavy for a particular server to handle, then it's better to have a read and write service separate. So
even
it
the
depends
even the
on the
database even
yes,
the database sources, right? Like the DB. So read and write DB should be different here.
yes, yes. If read and write volume are too larger, we should write in a, let's say, some master database, which will be replicated to some other database nodes, and we can read from the replicated nodes, but we will write on a single node.
Okay, sure.
That is one of the strategy of replication. It's called single leader replication.
Hmm. Okay. Okay, fine. So back of the envelope estimation, we can do similarly, like I have given these details, like similarly, it's mentioned in the first chapter if you go, like how do you calculate. So this is how we can calculate the QPS and everything like that. So it should be an approximate thing, not an exact thing is not expected. So this is fine. Now we have established the design scope, like what is the functional. So one thing I would say, it should be available, highly available system, and another thing should be, it should be for uh, not consist. I don't think consistency is a concern here. So maybe good
We are
partition,
okay with eventual consistency.
yeah, partition tolerance we can say as well. Cap theorem. So we can say that different network. I think network bandwidth. It should be same. So does anybody want to like chime in for partition tolerance? Like, uh,
So it's not required actually. So every system you design had to be had partition tolerance. This is kind of given. So
okay.
it's we don't need it to mention it to interviewer. Like
Hmm.
so certain things like security
Yeah.
and this thing we should not include in the discussion. It takes unnecessary time, and we only
Hmm.
have 35 to 45 minutes for this discussion.
Okay. 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 Sure. So we can say it's highly available, and this looks good for now. And let's move on to the design and how. So here the author is talking about we use like.
Should we include versioning here in file? Like, for example, I uploaded a same file again. Should we include versioning in requirements or not?
Uh, you can write in the extended requirement. We can discuss it later. But since it is not in the book, let's ignore it for now. But we can discuss it later when we complete the chapter for the extended requirement. How if we want to implement versioning, how we will do it.
Yeah, but I don't know if Google Drive does it or it doesn't do for the same file. But I think
Even
Dropbox.
I don't know this, but I think there should be some configuration given to the client whether he wants versioning or not. I know S3 as an object storage gives it,
Mhm.
so we have a choice that we want versioning for the object. In this case, our already written object will be immutable. But and if you want, you can ignore that requirement as well. But for Google Drive, I don't know. We can look into it later.
Yeah,
But
versioning, I mean something like that. We can keep a copy. We can keep a copy. By copy, I mean we can keep the, let's say we write a data into a file, then we can keep at regular intervals, we can keep a journal or kind of uh, journal or snapshot versioning of the data. And so that, let's say we have like what was the data at this given point of time. Then something, I'm talking in terms of collaborative editor, like they generally keep the versioning. When you open a Google Doc and you write something, then they keep a versioning that which user has written at what time and something like that.
Mhm.
yeah, I agree. But let's go with the functional requirement as of now, and let's discuss versioning later when we complete the chapter.
Yeah, yeah. Okay, somebody's trying to join. Okay, okay, sure. So let's move on. So single server, a web server upload and download files, database to keep the metadata for user, login info, etc. Okay, so we said. So I think here they are trying to explain like how would your folder structure would look like. So you have a single storage, and each user will have a user ID and its metadata and stuff, and they will kind of store. So this is the structure they are telling. How would your structure look like? And how would the APIs look like? Is going to be upload API, download a file, and get file revisions. I think they are saying file revisions, right? This is what you meant, right, Rohit, or somebody asked. We can maybe check like what is happening here. So upload a file. The format is an important thing. Uh, mm, so actually, I'm not able to understand this properly. So because the details are missing here, I think. Hello.
Yeah, I'm just trying to read it first. Yeah, so basically it is saying there is a single API upload, but for larger files, usually what Google Drive and other service provider are doing, we have something as resumable upload. So let's say the file size is 5 GB and you transmitted 1 GB, but after that there was a network failure or maybe your laptop goes offline. So after you came back online, it will start the download from there. It will not again retry from scratch. So this is an
Okay.
important feature for user experience.
Okay, so you mean that it is when the user is trying to upload the file, then it should be a type. There will be a type resumable, whether we can resume it or not. So if this is resumed, then the file gets resumed. Okay.
Yeah, so they are talking about two file uploads here, two types of uploads here. However, I think it should always be resumable. So even if it is a small file
Hmm.
or a large file, there should be a single API, and we always want it to be resumable. So,
Yeah,
but
agreed.
I don't know why they are introducing a new type for this. Like, there is no use case where you don't want it to be resumable, even for the small files.
The thing is, it should not be an option to the user, right? If he's trying to upload or download, it should be complete, whether it's a big file or small size, big or small size. But there should be an upload or download limit, maybe.
Yeah, I think let's
I
say
agree.
if there's a photograph, right, you want to upload it, then if it's not able to upload, we simply show an error that yeah, photo
Yeah,
is not uploadable. And if let's say you are some heavy video you are uploading, then actually there could be some network or latency issues, and because of that you might want to resume the upload, something
yeah,
like that. Yeah,
So I agree with Purnima that this should not be something specified by the
user.
customer
Yeah.
user.
yeah,
It should always be default as resumable.
by default, yeah. That should be a part
Right.
of.
Just to add to that, so basically when files are getting stored, we store them in form of chunks, right? So let's say there is a file, there are 10 chunks and 5 chunks are done and the network is gone. So the next upload or download should be happening from that chunk only. Yeah, so
Yes,
this is something that should be there. It's not a functional requirement to have it in a chunk-based format.
Okay. Okay, makes sense.
I agree. That is the approach for resumable upload.
Hmm.
Yeah.
Then download, I think, is fair, like where you want to download the path and all is mentioned. Then file revisions, the path to the file, you want to get the revision history, the maximum number of revisions to return. Okay, SSL and data transfer.
Should
Uh,
there be path in upload API also or not?
sorry.
Like, should there be a path in the upload API also, like, where a particular file has to be uploaded, or
Mm,
should be?
No, but if, in remote storage, you don't decide where it will be stored. It's the service provider that will decide.
yeah.
And
So
whenever you want to download, you will just specify the path where you want to download it. But how to fetch that file in the remote, that is the service provider
yeah. So
problem.
here, if you see, the service provider has decided that against a user, they will keep this like this, something like
But
that.
user can have also have its own folder, like an user one. And if I want to upload on a specific folder,
Yeah, but that is just a user is able to see, right? But actually, where it is stored, that they will take care, right?
mhm.
That is just user specific thing, but here the storage would be for n number of users.
So I think Rohit, how that should be done is it should be there in the metadata. Like this file is a parent of, it's a child of that directory. We can specify the metadata.
Hmm.
But when you upload it in remote storage, it's not uploaded in that hierarchy. Like it can be stored anywhere, even in different servers. Maybe your parent directory is in a different server and your file is in a different server. When it downloads it, it tries to read that metadata and figure out that this file should belong to this directory. Then it decides.
Okay.
It's like assembly during download.
So you mean to say we have a Google storage, right? All of us have Google storage, and we have folders. We segregate our files in a different folder structures, right? So when we upload or download from that particular path, you mean to say internally it is not maintaining that path, but it is having its own storage? Is that what we're developing?
Yes. So that hierarchy is not followed in the remote storage. Remote storage tries to figure out some way to store it independently, and then during download, it figures out like how it should look to the client.
Okay.
I think
So
it
what?
takes where from whichever on which current path you are there, it takes that path only to upload.
Hmm.
Yeah,
Maybe
so when as a user perspective, if we see, it tries to mirror whatever my path is there in my current. Let's suppose I'm uploading my folder, it tries to mirror that path. So as per user perspective, that's there. But when I'm thinking as a developer or as a company, I do store them in the distributed format, like you mentioned earlier.
Also, we map it out to a different location.
Yeah, so those chunks I mentioned. So what I have seen doing in practical world is they chunk it out and they store the metadata. So when we have to retrieve that file, we read that metadata and we get those chunks from there.
I see. Okay, okay. And then it presents to the user in a way that we see the folder structure.
yeah. Also in download API, like, is this the remote path or is this the path of a local path?
Uh, Download a file from a
This is the
Google
local
Drive.
path you're mentioning where you want it to be downloaded. You don't know
Ye-
the remote path. Like client won't know the what is the remote path actually. You just won't know.
Yeah, I think this is a bit confusing because they have not mentioned whether it's a get call or post call. So if
So
you
we can say this. Yeah, sorry, please go ahead.
so here API this is a third party like Google API which we are calling that we want to download this file. So ideally it should be a post call, and it is giving the structure. For example, you to go to this, you do a right click or something and you say download something like that. So it will navigate the path and make a call.
Mm, I
It can
don't.
be a relative path to our folder structure. So I know in my folder structure that in my recipes particular file is there. So I just send that path, and it will be in the remote path. It will be get mapped, and I'll have the file.
Yeah, that is what I think. Maybe people can
Yeah.
disagree, but why but I think what
Yeah, I
this
disagree. I think it's a get call, and this path is a local file path in your laptop where you want to get. get downloaded.
Okay, okay. Like you will say that I want to download in this path,
In
but
get to
why would you give this recipe soup and
and
this stuff
also
like?
in get
You
to
can give any
API,
path
there is no
where you
body
want to download
actually.
it.
हाँ, मतलब yeah. So what I feel in the context of this discussion, like see, it is a user one. So user one is making a call. It will say I want to download this particular file. So this is the folder structure, and there would be multiple files, right? So which exact file you want to download? So it will give that path. Otherwise, how would the API know? Uh, and secondly, like you can also pass that parameter, like where you exactly want to download it.
Mm.
Yeah, I think it will be a remote path actually, and
So there
it's
could
the
be like multiple parameters, so that we can discuss. I think that is not required right now because we are not going deeper into the APIs. It's just on high level. Yeah, because there is obviously not a single parameter. There would be multiple API parameters, right?
Okay, okay, sorry, my bad. I think you guys are correct. I got confused. I thought that file ID is there in the path, but it's not there.
Mhm.
So it should be there in the query
Yeah, yeah.
parameter.
Actually, this part API part is incomplete.
Yeah, I agree. You guys are right. It should be a remote path in that
Okay.
case.
So let's move on. So this is move away from a single server. Then your device can get full. Okay. Users are not- Then now they will talk about like if your storage is full, then how will you distribute the capacity? Like how would you store in different servers? So they are saying that the first solution could be to shard the data so that it is stored in multiple storage servers. So based on user ID, you can do the shard that this user, these are the shards. So all the data for that user will go to one shard, then another user, it will go into another shard. Or we can define that user 1 to 100's data will go in shard 0, user 100, 1 to 200 will go to shard 1. Something like that we can do, but there could be some problems with it. Amazon's S3 storage that offers industry level scalability performance. So here they are talking about Amazon S3, like how it distributes the data. So we are solving a similar problem for storage, what S3 has already solved. So the region is geographic region and can have multiple data centers and cross-region replication. So redundant files are stored in multiple regions to avoid the data loss. So there is a concept of bucket, I think, where they are doing the replication in the regions and even across the regions. So same region replication will also be there and cross region also. For example, US or some data center would be there and your data would be replicated.
maybe in the same region they are doing backup, and then for other users they are doing a cross region.
Mm, yeah, I mean that is subjective, but yeah, how they are doing, I'm not fully aware, but yeah. So then how would you optimize it? So add a load balancer to distribute network, that is fine. You make from different devices you call API servers. You will have a metadata DB for storing the metadata related things and file storage. Okay, this is fine, I think, to ensure availability and durability. So here they are just talking about replication, I believe. So in the same data center, you will replicate the copies of that data so that there is no data loss there. And also across region, also we need to support for multiple in different geographies. So this could be one of the, your questions, clarifying questions in the beginning that is, I mean, is it like multi-region storage you have to design or it's a thing other, so that you can isolate the discussion, right? You won't be discussing if it's a multi-region or single region. So if it is a multi-region, then you have to touch upon those points. Conflict, in case of conflict, then how would you handle that? That is handled through versioning. So they will version different things, and there would be some worker threads. That is my thinking that there would be some worker threads, and they will kind of keep the versions and make them sync like who has uploaded what, right? That is the thing, right? If there are two users, because we can share it also, right? We can share that folder, and if let's say the same two different users are accessing the same folder, then there could be a conflict. Hello?
Yeah, I'm reading it.
Yeah, sure. So our system, then user one, user two.
Okay.
So is it like the conflict should be managed in a real time, some kind of this?
This can be offline process, I guess, not real time. But
No, if we all are seeing a particular folder, a new user comes, add a file. It should be a real time, or like it should be
mm,
uh, like a file gets added and all users should see that file. or one has to reload the screen, or then it comes.
Yeah, maybe it can, what it can do is it can keep it in some cache or something, and when let's say a user refresh or after regular interval, the user can the cache can refresh and user will be will be seeing the updated data. Something like
Yes.
that could be done. I'm not sure if that is the right way, but yeah.
Uh, hey, by the way, can you go a couple of pages before, like the functional requirement?
Okay.
So it's just weird. Like they tell like Google Doc editing and same page, go one page above. Like they tell like features are not discussed in this chapter, like Google Doc editing and collaboration.
Hmm.
So yeah, like at one point they are discussing that this feature is not discussed, and then after 2 pages they are actually discussing the
No,
same things.
actually, just to correct you, they are not discussing the Google this thing. They are talking about the file, right? So if you are, this is one of the functional requirement where the user can share the file, right, to multiple users, to his family or friends. So if let's say you share a file, share the folder, then they will be having the access to that folder and they can upload different files on that. So there can be some conflicts which can happen, right, if two users are accessing the same folder. So in that context, I think here they are talking. It's not about the collaborative editor. Uh, do I make sense, or somebody has another opinion?
I thought Nis's point is valid. Like
Yeah,
they said this is not required, but they're talking about the same thing.
Okay.
but it's okay. Move on.
No, but in terms of folder structure, they can be talking about it, right? If we are
So
sharing the folder.
then you won't get a conflict. Let's say I create a separate file and you create a separate file in the same directory. It won't generate a conflict. A conflict will only be
Okay.
generated if we are trying to edit the same file. Let's say
Oh, okay, okay, got it. Yeah,
let's say
understood.
in that
Here they are clearly telling the same thing. I was just assuming, I didn't read it through, but
mm,
yeah, here they are saying ki update the same file at the same time. This doesn't make sense. Yeah, agreed, Nishit. Yeah. So how can we resolve the conflict? So let's not deep dive into this. Let's don't get confused. Let's move on. Yeah.
yeah, but they are saying if they are trying to edit at the same time, so first edit will work, and the second one we will show error that there is a conflict. Your edit won't work.
Okay. Uh,
That's
Also, just want to add, this is completely out of topic, but there is something known as vector clocks, which can like find the conflicts and then they can resolve it at real time. So like it's not
okay.
given in this book, but vector clocks can be used. It's
Okay.
a out of topic discussion.
so you are
Yes.
saying if there is a functional requirement for collaboration here, then we have to introduce something like clocks to make it work.
Yeah, that can be used. That's what.
Okay,
Also, and correct me if I'm wrong. Vector clocks can only be used in a single leader database. They cannot be used in leaderless database. I'm not completely sure about this one, but if someone has more context,
no, I don't think so. DynamoDB is a leaderless replication strategy it uses, and they also use vector clocks to fix it. So it is used in leaderless application as well.
okay, I'll read more. Yeah.
Okay. Yeah.
But
So
can
maybe.
there be, just one question? Can there be conflicts like if like two users are uploading the same file actually?
Yes,
In that case,
they're talking about the same thing here actually.
yeah, like the other thing is talked here, like if you two users are updating the same file,
Hmm.
like I'm saying, like they are uploading the same file actually,
Uploading the same.
same folder or same script.
So you mean like we both of us have a PDF copy of this book, assuming, and we both of us are uploading in the same Google Drive folder. That's
Yes,
right.
yes,
Then,
yes, yes.
then probably versioning will happen. I'm not completely sure, but I think suppose your write goes first, then yours will be version 1, mine will be version 2, or we'll see two copies like this one shown in the screen. One will be just system design interview that you uploaded. Other will be system design conflicted copy that which I uploaded. So and then you have to ask the user to resolve one. So probably yeah, that's
So in my opinion, I think the second thing that Nishit said should happen because file name is not a unique identifier for a directory. It should be a file ID for the service. So when you upload two file names, it won't treat as a same object. It is like a different object. Let's say we both are trying to upload this PDF. It won't know that this is the same PDF, even if the file name is same. So I think two copies will be separated. But if there is a conflict in the file name, it will just append underscore one to
Yeah. Yeah.
for the.
yeah, I
Makes sense. Yeah.
yeah
So
I agree with that.
like in this system, like apart from updating the file, like there will be no conflict scenario. Like if the same file is modified, then conflicts can occur. Otherwise, there will be no conflicts. I think so.
Yeah, and if I'm trying to write in the file and you delete it, that's
Yes,
also
yes, yes.
conflict.
And
Hmm.
then there are like different techniques like CRDT or maybe last write wins or something like this. Uh,
Yeah.
like according to which like there are different things where these conflicts can be
Sure.
resolved.
Let's after this chapter is finished, let's try to discuss that functional requirement as well when we need collaboration.
Yeah.
So we will get more idea, or we will try to read some other chapters
Yeah.
which touch
Maybe
more.
designing a Google Doc would be a good
Yes.
thing
Sure.
for
So
that.
let's park it for now. Just note it down. We can discuss it later.
Yeah.
Any other chapter.
Yeah. Maybe we can deep dive into this vector clocks and stuff like. So looks interesting to me. So yeah. So yeah. So here, like in the HLD for this, let's see what it happening. User goes. It calls block servers. Then there's a cloud storage, which can retrieve the results and all, I guess, and the notification, long polling, metadata cache. Cold storage. What is cold storage? Any idea on that?
So cold storage is like as a Glacier, files which are not used for a long time. For example, like you have some report of 2 years ago, you have some
Hmm.
blood report or exam
Okay.
report.
Okay.
You don't access it that often,
Hmm.
but you just want to keep a copy somewhere.
Okay.
So cold storage is very cheap, but it has, I think, high latency. The time that it takes you to retrieve is more compared to that.
Okay.
So
So is it like when we are designing some storage system, is it like the third-party API is separate for cold storage than cloud storage?
Amazon has separate. I don't know about Google.
I think this looks to me like a Snowflake logo. I'm not sure if Snowflake does this, but yeah, I'll check maybe.
In AWS, there is a service called AWS Glacier. That
Okay.
is
It's actually Glacier logo, I think.
So does
Okay.
internally object S3 uses this cold storage thing for the inactive users? Any idea?
I don't have idea, but I think the user has the option. They want to opt in to Glacier or not? If they opt in, then S3 uses.
no,
Probably.
what we did in our project is we wrote some kind of a lambda which picks up certain files based on timestamp and move to like backup in our Glacier storage.
So move from S3 to Glacier or move from some other storage to Glacier?
No, move from S3 because
So
the
that is
file.
something your service is doing. It's not S3's responsibility. I'm asking whether S3 internally uses the Glacier for the inactive users or inactive files that are not retrieved from, let's say, last 1 year.
Actually, the files can get like internally replicated. Like we are not copying whole file into our service. Like it's internally they are being copied. Like we just have to give the path in the same. The S3 and Glacier should be in I think same region,
Uh,
and
yeah, go ahead, Rohit.
yeah, then they could be internally be copied from there. I
So
think AWS manages on its own.
just to answer the question, actually Google it. Amazon S3 does not internally use this Glacier. We have to either opt in or call into the other storage. And also, I think I might be wrong in this one, but it does not necessarily have to be in the same region. Cross region are also allowed, like S3 Glacier. But I might be wrong in this one also.
Okay.
Okay.
That makes sense.
Maybe we can
Okay, I
explore
think I will.
this.
We will get the answer later in the
Yeah,
chapter. So we
we
are
Yeah,
can
just
yeah.
read
Let's
more about S3 and Glacier interaction, maybe how
yeah,
they
let's
work.
discuss later.
Yeah,
nice.
fine. So,
So I think there is a like life cycle of files in S3, and it gives us the option like, do you want to move in Glacier or not?
So
Uh,
let's say you want to move in Glacier. Will you use the same S3 APIs to talk to those Glacier objects, or you will separately integrate with Glacier, your service?
no, S3 can internally fetch it from
Yeah,
Glacier.
yeah. So that's why that's what I was asking actually.
Your latency actually
Whether
increases.
S3 provides this functionality that it can internally move to Glacier. That's what my question.
okay. Okay, so that is fine. Then block servers are responsible, I think, for chunking of that data. So it is dividing it into chunk and giving a unique ID. And I think that is getting stored in some metadata, although it's not mentioned here. So it would have some it's database where I think that data would be stored, like which chunk has. Please correct me if I'm wrong, but yeah, that is what I understand. To reconstruct the file, blocks are joined in particular, and for a block size we use Dropbox as a reference. So let's say there is a 20 MB file, we will divide it into 5 chunks of 4 MB, and then each chunk would be having an ID, and once you are retrieving, you want to read the data, then you will combine and aggregate all of them from that cache, okay, not a cache but metadata DB. Yeah, makes sense. Then the file is split and stored in cloud storage. In active data we discussed this, API servers. So generally, like I wanted to discuss one thing with the forum is that we always put this API server here, right? And then whenever a user is filing a request, it goes through API servers, and let's say there are 3 services, right? So it makes a call. So does this API server stores all the information about all the services, or what is the purpose? Like again, we will have load balancer and other stuff here in this layer, right? Load balancer. So this will be responsible for your authentication and rate limiting. But what is the purpose? Like, do we keep a copy of this API server also? I'm just trying to understand like what is the purpose of this API server, which let's say talks to your some service like upload service or etc.
So are we talking here about API gateway or API server?
API servers, like whatever HLD I have seen in books and blogs, they keep an API central server where different APIs or services are routed towards, right?
So, in my opinion, they have separated load balancing thing and the API server separately. But in most of the services right now, it's kind of combined in a single API gateway. So API gateway kind of does both functionality. It also does the load balancing thing as well as the functionality of the API server, that is authentication, authorization, rate limiting, and then orchestrating and sending it to the particular service. Different downstream service, whatever they require. So here in this book, they have just separated the functionality. So load
Okay.
balancing will just basically send the request to different API servers because there will be multiple API servers, and you want some way to distribute the load. Now API server will do the auth and auth key part and send the request to the correct services. If it's a write thing, it will send it to separate service. If it's a read thing or downloading, then it will do orchestrate it to a different service.
Okay. Okay, so mostly for authentication and stuff, we are using here API servers. So that is fine. Then metadata stores data, block, versions, everything stored in the metadata DB. I think this is the metadata DB, and it also has a cache. Okay. So some of the metadata cache for fast retrieval, then notification, like when you have uploaded, it will notify, and there can be a push notification. So I think this is the push flow and this is the poll flow, pulling. Yeah, so okay. Oh, okay. It's kind of a pub sub. They are saying that it's a pub sub. So notification service to clients and certain events happen. It's kind of notifying all the users for that edit files edited or removed. File can be added, removed, or it can be edited. Okay. Okay, this is fine. Then backup queue stores info. Then this is the, I think, the interesting part, like how you are doing chunking and all. So uh, do we want to discuss this in this or shall we? It's 10:18. Are you guys okay to continue? How much is left? I think 4 or 5 pages are left. So maybe we can do that right in 10 minutes. Hello?
Yeah, we completed, I think.
Yeah, let's do it. Yeah. So design the deep dive. So in block servers, you have large files and they can be updated. And two optimizations we have to do instead of the whole file. So whatever the block of your document or file is changing, uh, that those will only be updated, like those chunks. For the syncing, some sync algorithm would be there that would sync the data. Whatever the delta has changed, basically. Okay. Compress the images and videos. Okay, this, so I think what here they are telling is there is a block server and it has two responsibility. One is compression and another is the delta sync. So you first divide the data and let's say there are c1, c2, c3 chunks. So only c2 has changes, right? So we won't touch c1 and c3, only we will update c2, so that it will do this delta sync. And compression is like to optimize the storage. This actually is being used, right? Bzip2, you can just it's a runtime thing, and it really whenever, let's say, I was reading about it, so most of the Java apps, they have this in their Docker file. So this kind of compresses, like whatever the data transfer is happening, that also it compresses and send. So let's say you are sending 100 MB of data, so it will compress the data and then send it over the network, because network calls are expensive, right? So this is compression. Then encryption is also important. So I think here the author is taking care of all the things. First, you divide the data into blocks, and compress each block, and then do the encryption. Okay, this is what he's telling here. Let's move on. Network traffic, that is the purpose. You are the bandwidth, the network bandwidth is getting optimized, which was one of the non-functional requirement, if you guys remember. So yeah. So strong consistency, file to be shown different by different clients, right? Eventual consistency model. Data is in cache replicas, invalidate the cache, and achieving strong. But why would you need a SQL here, right? Because you want it to be eventually consistent.
No, I think we decided to be eventually consistent, but the book is saying it should be strongly consistent.
Hmm.
Uh, I don't know why they are going for a strong consistency here, but I think it's okay for the system to
Hmm.
show the changes after a while. So
Yeah.
it depends on the requirement. If your interviewer says that design for strong consistency, we have to follow this thing. If we design for eventual consistency, that is okay.
Yeah,
Okay.
actually, even I feel like eventual consistency should be the one. There is no need to have a strong consistency. I don't
Hmm.
know why the book is writing like this.
Yeah. Maybe for that reason we can use Cassandra here. Maybe for that eventual consistency for the storage.
Oh, so this is for which database actually? What we are trying to store?
the blocks, right? The data, the chunks.
Okay, those chunks. Okay. Yeah, if we don't need a strong consistency, then I think NoSQL is fine. If we need a strong consistency, we have to plan for some SQL database.
Mm.
So does S3 or any object storage, do they provide chunking internally, or like is there a need to actually use Cassandra along with S3?
Mm, I'm not sure whether S3 gives chunking internally, but even if it gives, we have to chunk it before because those network bandwidth will be consumed. So we cannot send our whole 10 GB data to S3 first and then wait for it to do that chunking part. We have to do it before that, way before that. Because at the client side, we want resumable uploads and downloads, right? So how we will do that? We cannot rely on S3 thing here. Our service should provide the chunking thing, and that's why we need some kind of a database to have that chunking. All the metadata stored in some database.
Yeah, exactly. So if you see this flow, right? I mean this flow. So here, what they're doing is before you are doing the storage, right? You are doing everything. So this is you are first dividing it, and then you are compressing also because compression is also important because you cannot store 100 GB data, right? You have to compress the data and store. So there they are using some compression algorithms also, and then encryption, and then you will store the data. So these are the before storing the data, these are the three steps which is happening in the block servers itself,
So what is exactly block server?
which is responsible for dividing your data.
It's a separate service we have.
Okay. And I think S3 gives us features of compression and encryption basically. So
Okay.
all your files are basically encrypted, and then you share a pre-signed URL with the.
Okay, but here S3 is kind of used as a third-party service, right? So we
Mhm.
have to do encryption and everything way before that. So we should also do provide that support to our users. Here, client is not directly interacting with S3. He interacting with our service, that is Google Drive, and then we are talking to S3. So Google Drive also had to support this encryption thing, chunking part, and everything, and that's why we need block servers.
Yeah. Okay.
So
So
block server is like a web service only, like
Yes,
which.
yes, yes.
okay.
A
So
separate
block
microservice. Yes, Nishant.
No, I was like, so block server is a web service which has encryption and this compression. So that's true. I'm just thinking, what database does the block server use, or is it like, does it? I don't think it will store it in memory. It is going to use some kind of a database. Does it use the same S3, or does it use Cassandra as that person told? Like,
Yeah. So I
No,
think
for metadata, it won't store a cloud storage. Like means something like S3 won't be used here. S3 is basically for storing larger files, object storage. But if you want to store a metadata, you have to pick some database. Now here, the requirement as per book is the strong consistency. That's why they are going with this SQL database. So anything Postgres and MySQL is fine. Let's say our interviewer want us to go with the eventual consistency model. Then I think Cassandra, MongoDB, or DynamoDB, even all three are fine. Any NoSQL database is fine there.
yeah, actually yes. So if we have to design this metadata schema for metadata database schema, then these are the tables and the interaction: user ID, block ID, right? File version. So these things are, I think, updatable. You can update the versions ID, right? But block ID would be unique. That is what I think. Once you divide the blocks, then you can kind of let's say whenever an update is happening, right? So do what I'm trying to think is like, can we use consistent hashing? Like, let's say if an update is happening in a particular block ID, so will that improve the latency aspect?
I didn't hear your question. What is the
can
question?
you repeat your question?
So my question is, let's say you are dividing it into different blocks, the data, right? And if an update is happening in a particular block ID, right, then you can we use consistent hashing? Let's say we obviously have to update it, right? So something like consistent hashing can we use here? I mean, to update that particular block for
I
reading,
mean,
reading and writing purposes.
if you want to update the block, the database queries can do it.
Okay.
Like, yeah,
I think you are asking like how will we identify the block basically?
Yeah.
Basically,
Yes.
basically we
Something
make
like while we are reading it, not writing, but when we are trying,
yeah,
when another user is kind of trying to read the data.
like for example, somebody change some block, and then we calculate the some kind of a hash, and based on the hash, if matches with the already stored block, then we identify a particular block in the metadata. Something like this. Are you asking?
Yeah, exactly. But yeah, I'm also fine with queries, but like if we see a strong scale, like, then you have to, if you're doing a query, then you will end up querying all the blocks, right? That particular block ID.
No, they have third column as block order as well. I don't know what is block order.
So
Okay.
only blocks that have changed will be downloaded, right? Not complete file. You are okay with that. Now, what is your question?
No.
Yeah, so my question is, let's say there is an update, okay? So
Mhm.
my API, whatever is there, it will send key, this is the block ID, this is updated.
Okay.
Okay, but these blocks are kind of divided. It will get updated. But when say the another user, like concurrent user is there, it's trying to access like what block has changed. Then will it query like all the blocks?
No, so as a notification, you will get that which chunk has been updated, right? And now the client will try to fetch only that chunk. So let's say block 2 and block 5 have been changed. Now user will try to download only those blocks. If he already have a file, if he don't have a file, it will download all the blocks. But let's say he had a file. Now these two blocks have been changed based on the timestamp. So it will only download these two chunks from the block server, not the whole file.
Okay. Uh,
And how do we know like if the block has changed or not? Like how will we come to know?
So based on the timestamp, let's say at the client side, your file was downloaded at 10:15. Now the server knows that block 2 and block 5 was modified at 10:25. Only for that, the timestamp is more than the timestamp you have in your file. So based on that, it can decide that which blocks have been updated after you have downloaded that file.
okay.
Yeah, I think that is also one way. Another way is like, there is a message queue where events are being sent. The event is that this block has been updated. So so as soon as you log in, that message queue will try to pull the data, pull all the events. I think
Hmm.
that's also another approach.
Yeah.
Yeah, I agree. I agree with Nishant's statement.
Yeah,
So
that is
that's one notification
yeah.
service.
Yeah, so yeah, I mean, yeah, maybe that is a better approach using a message queue.
It will notify the client with the uploaded with the modified chunks
Hmm.
ID.
Okay. Okay, but just I was trying to think whether we can use something like how we are storing, right? We can store it into nodes in a circular ring, and if some consistent hashing can be used to optimize it. So I was just thinking maybe that is not the right approach, but yeah. Anyways,
So I don't think consistent hashing is required because block servers are basically stateless servers. So any kind of load balancing can work here. Even round robin can work here. You don't need to figure out a particular server to fetch a block because server will talk to the blob storage thing and it will fetch the chunks from there.
okay,
So any kind of load balancing round robin is going to work. We don't need consistent hashing for the block servers.
okay,
Yeah.
okay,
Also, Vishal, one question. So consistent hashing is primarily used for horizontal scaling so that the horizontal scaling takes less time and resources. It is actually not really used to identification of any tables or resources. Like, is that correct? Or
I did not understand your question, but consistent hashing is used for the stateful server. So let's say in every server, the data is sharded, and some server have some data, and some other server have some other data. Now you need to figure out to which particular server our request should go to. So consistent hashing is useful for that because you will do the hashing on the key ID, and you will figure out that for this particular key ID, our data is stored in a particular server.
okay,
And
okay,
yeah,
okay.
I think he was talking. Maybe he might be talking about sharding and all.
yeah.
Uh,
I was thinking on like the storage, but let's not over complicate it. For now, let's.
So
I
just for clarification, block servers do not hold any data. They are stateless servers. Our database and our cloud storage are the stateful servers.
Yeah, exactly. So, see, I was thinking like if let's say this is a block server, right? This is one server, then you will have a replica of it, another server. Okay. Now, maybe then a user fires a query that I want what has changed. Okay, what has changed? So you will go, and each block server can have different state, right? It will be eventually consistent, but it will have different state. So, how would you handle that kind of situation? Like, I mean, so will these block servers will be in a kind of a ring or something, and then the data is replicated? So can we use consistent hashing there, or uh, something like that in terms of storage, not in terms of servers, but yeah, something like that. Maybe I have to revisit it, but yeah, just thinking on those lines.
this can, I think, maybe if there are updates being happening to a particular more updates being happening, maybe a hot partition problem can occur.
Okay.
Uh, uh, or maybe there is a traffic on a particular files there.
Hmm. Okay, sure, sure, guys. Let's not discuss more. Maybe we can. I can come back on this again, like what I was thinking, and complete my thoughts. So yeah, it's fine. Then the user table we all have checked that what is the file and all. Upload flow, better understand the sequence diagram. So here, user is making a call. This is the sequence diagram. So notification happens. This is how the interaction is happened. There are two different clients. Then you have block servers, cloud storage. Makes a call to API server, makes a call to the database, and notify the change. Then the changes which are notified are driven into client 2. Then this is about the write flow, I think, and this is no, this is about the read flow, is it? Uh, add
Both are right flow.
both
One is
are.
for the file metadata. Second is for the file content upload.
This is for the metadata, is it?
Yes.
Okay, this is for the upload file. Here the blocks servers comes into picture. Okay, so meta related things you don't need block servers, cloud storage. You just store it into the DB. But for upload file will require this these steps.
So I think naming is not great here. Instead of block server, think it is a write service, and API server treat it as a metadata service.
Hmm.
So, so API service is handling everything related to metadata, read and write of it,
Hmm.
and this block service or the write service is handling the upload and download part of the file.
Yeah. Okay. Then two requests, I think they're talking about the same thing. So maybe whatever we have just gone through, they are reading about it, like how it's done. So anybody has any questions on this? So maybe then we can, all else we can skip this part. Okay, I'll take that as a no.
Is
So
this even been asked in an interview? Like in an interview, do they even ask like sequence flows or
no,
something?
no, 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 that is not required. Yeah. It's just for, like, they might ask you the flow, like how you will draw an HLD, and they will ask how is the flow working. So in that case, eventually you are telling the sequence diagram, but but yeah.
Verbally, you're telling the sequence, like from client, the request is going to API service,
So
then to
if
database. You
yeah,
will draw that,
uh,
but not the sequence diagram.
but yeah, so it should not happen that your design is different and the sequence you are telling is different, right? So your design should be aligned to the flow. What you are thinking, that should be there. Even sometimes what can happen is they will tell you a problem, you draw an HLD, and then they will ask you that can you write that LLD for it? So when you write an LLD, and if let's say your LLD is not aligned with your HLD, then also it's a problem. So uh, from HLD, I means the schema and stuff, like where you are doing the classes and all, like the entities basically. For example, here you have met workspace user ID, so you will draw a user DB, you will draw a block DB, something like that, for example. So it may not happen that data is getting stored in some other DB. So that is what I'm trying to say. So basically your HLD, LLD, and your flow should be aligned for the problem you are solving. Okay, the notification service. Okay, this is the download flow. Upload flow makes sense. uh, Download flow is like notification. Okay, the changes, like whatever the change has happened, will be put to the client. Then it will get the data from MetaDB and cloud storage also, and those blocks would be downloaded. So this MetaDB stores the data. I think what are the blocks and all, right? If I'm not wrong, block ID and all. So it will say that which block has changed, and then those block would be returned here, and then it will make a download for those particular blocks, and those blocks would be downloaded. So let's read it once. So okay, yeah, same thing only. It will first return, the API server will return what all blocks have changed from the metadata, and then those blocks would be downloaded. But this
I
is
think
weird. I mean, this doesn't make sense, because when you are downloading in the file, you will entirely download it. Why would you download the chunks what has changed?
to save bandwidth, save it will take less time.
Okay, but I mean, you download the entire thing, right? You don't care about like what has changed or what file is added.
No, let's say the file is really big of 5 GB.
Hmm?
So every time a change has happened, will you download the complete file again? That will be a waste of bandwidth and time as well. So that
Also, yeah, go ahead.
that's
Go
okay.
ahead.
Yeah, you can continue.
No, no. I was just thinking that maybe the client or the cache has the copies of the other blocks. So, like when you say, like, why is there only one block is being downloaded? The other blocks are already present in the cache. Maybe that was the
Oh,
question.
understood. Yeah, that makes sense actually, Nishit. So I think here what has changed makes sense. It will update the cache, and you don't need to query all the blocks to download the file, something like that.
Yes, client already have the complete file. Only
Uh,
it will ask for the changed
okay,
blocks.
understood. So I was thinking in perspective of the download API, right?
First time
So
download, right? You were thinking what happens when you're
yeah,
downloading for the first time.
yeah, yeah.
Then you have to download complete file. So,
Yes,
but even then, chunks are useful because you can do it in parallel. So you can have a 10 threads in client, so they will be downloading 10 chunks in parallel. So
yes,
it will be fast instead of a sequential
yeah,
download.
yeah, makes sense. Thanks. So notification service to maintain file consistency, inform the client. I think this is driven by that MQ and all, right? The notifications, what all events, and also it will all the messages, what all the events would be triggered, they will be put into a queue, and notification service will inform all the clients using a PubSub model that this has changed. That is what they are talking about. So either the client can poll the data at regular intervals, like whenever push and poll model, right? So whenever something has changed, it will poll the data. If something has changed, then the client can poll the data. Server will tell that something has changed. Else, server can also push the data sometimes. So here I think they are using polling, because when something has changed, then only you need to update, right? So this is for real time, I think, WebSocket,
Actually,
because
I was reading an article. It is given like S3 on its own can handle chunking and all. So we don't actually need a block server for chunking, and it internally handles.
But Rohit, problem is that if when I have to upload a file, first it will go to S3 as a sequentially, right? Then it will do the chunking. So there is no benefit of chunking that I'm getting before uploading it to object storage.
No, it's written like internally, like if you upload it again from the client side, it
Okay,
uses.
from the client side, you are saying S3 client will do the chunking for us.
Yes, like from the client side, there are two ways. Like one is using streaming, and then the other is like from chunking side.
Okay, got it, got it.
With-
But in that case, Google Drive client should do also support chunking here, right? Because we are not directly interacting with the S3 client, we are interacting with the Google Drive client.
Yeah, but actually that is fine that S3 is battle tested and it has all the capabilities. But here we are not concerned about S3. Here we are concerned about how would you design S3, right? So that is
No,
something like S3 we are designing here. So we are
no. We are designing Google Drive or Dropbox. We are not designing S3 here, just to be clear
no,
from the
Yeah,
start.
but here the references were of S3, right? So they were saying ki,
No. This block server and everything is a Google Drive or Dropbox design. That block cloud storage is the S3 part in that high level design.
but this is also a cloud storage, right? Google Drive.
Internally, it is using some kind of a blob storage. So S3 in functionality is very different from the Dropbox or
Yeah, so I'm not talking about in terms of S3. Like S3 is a different thing altogether. I'm just trying to say that we are kind of similar service, not exactly S3, but a similar service which has capability of storage, cloud storage.
okay.
Yeah, because here, yeah, but I think you are also right because this is like a Dropbox, right? This is not a service. So you are also right.
Internally, it is
Uh,
using S3 because internally it is using S3.
no, but
the
This
blue
cloud
side.
storage, that bucket is the S3 part actually.
the chunking part you are saying. Okay, this.
No. The web block service is talking to the cloud storage. That cloud storage part in the high level diagram is the S3 part.
Oh, is it okay?
Yeah, this is S3 or OCI object storage or any kind of object storage we
Okay.
have in Google and Azure
And
as well.
and this is like the third party storage, and this is like your metadata will.
Correct. And this is he said that cold storage can be AWS Glacier, so that is also a third party thing.
Oh,
I
and
think if we need control over chunking part, then maybe block storage service would be
okay.
necessary.
No, I agree with you, Rohit. If S3 provides it, maybe, and even in this case, the chunking should be done by the client side, not in the block server. Because when I try to talk to block server, anyway, that communication through the network will happen for the whole file. So it's better to have a chunking at the client side instead of a server side. So I don't know why
But
they are
I
doing it
think
on server.
like the main problem here is like how will you like if failures occur, like how can we resume basically like these many chunks have been.
That logic can also be there in the client side now. If for a particular chunk upload failed, it can be retried. That
Yes. Yeah. Then it depends upon client sessions and all these things. Like this can be managed by client
I
side.
agree. Client side logic will become heavy with this, but again, I think if we don't have this functionality at the client side, it is not very good user experience for the user. Because if I have to upload a whole 10 GB file to the block server sequentially, and it will do the chunking for me, so my experience will not be good at it. Because when I try to upload a 10 GB file, I might face network issues. I might maybe it will take 1 hour to upload the whole complete file because of my Wi-Fi network bandwidth. So that is not a good user experience. But if I have a chunking at the client side, so those parallel threads will do that the same work for me in 10 minutes instead of 1 hour. So based on this design, I only have concern with that. I don't know how actually Google Drive or Dropbox is doing it. I will try to figure it out more.
Yeah.
But that's my
So,
concern.
so Vishal, can there be any use case when the client will intentionally corrupt the data or maliciously send any wrong data or something? Like usually we don't have client because of these reasons. So, is there a use case in this Google Drive? Can there be any use case like that?
Yeah, I think there can be. Like you are right. If we introduce some logic in the client side, we have to be more secure. So I think maliciously many things can be done at the client side, but we need some logic in the server side to verify the fingerprint, to do the fingerprint and validate against it. And if it is malicious, ignore it. Some kind of logic can be there. But I agree
Got
with
it.
your point. There are some overhead we need to figure out if we are doing these things in the client side. I agree with you.
Yeah, that makes sense. Thanks.
Yeah, so okay, thanks. So let's move on. So here, polling we discussed, and then serve save storage space. So they are saying that easy to save space. Two blocks are identical if they have the same hash value. So if the data is same, I think not the data, but uh, redundant
I think
blocks. Okay,
it is the data. I think.
it is the data. Is it okay?
I think the hash value is calculated based on the data, and that's how. If I'm right.
Yeah, I think so.
Okay. So two optimization strategies for the data backup. So here, if the limit is reached, the old version will be replaced by the new version. Okay. And some files will be edited frequently, for example, every edited. Mm, so it's about like what you need to store, right? What useful things. So um,
Yes,
reason
we are
wait.
talking about versioning functionality. So the first thing they are saying that maybe we can decide to only save the latest 10 versions and we will delete the older versions. And
Okay,
second thing is that we don't need to update every version. If let's say in 10 minutes there are 15 version are created, then we can ignore intermediate versions and we can have the latest copy as a new version.
understood. Sure. And this is like we discussed, it was a good point. Like Amazon S3 is used and it is much cheaper, right? On S3. Then failure handling, load balancer fails.
So
Then
only concern I have is whether S3 will take care of that for me. Like it will migrate my files to Glacier, or whether as a client I need to do that thing that I have to switch between the storage from S3 to Glacier to again back to S3 if
you
required.
mean two separate integrations with S3 and Glacier, or just need an
Like who is
integration?
responsible for this?
Yeah,
Yeah.
I mean that should
So who is
ideally be
responsible for
taken
the
care
cloud
by this thing, right? S3
S3?
only, because it is up to S3 how they want to optimize it.
Yeah, even I think so.
Yeah. So we will just, as a business, like we will go and talk to S3 guys that we want, this is our requirement. How will you give us the storage? Then they can tell us, right? So I don't think we don't need
Yeah.
two separate integrations. But yeah, that's a good thing thing to discuss. Yeah. Okay.
Yeah, yeah. S3 I think will handle it. There are like we need to create some policies in Glacier, which policies are for like that particular object S3 can access it basically, and internally it makes a
So on
connection.
our behalf, S3 can talk to Glacier for those particular objects, and S3 will take care of
Yes.
switching those files for
There
us.
are we I remember there are life cycle policies we need to create, and
Mhm.
to whichever objects we can grant the policy that we can access it through S3.
Okay. Okay. Nice.
Yeah. So I think here they are talking about failure handling. So if your load balancer fails, then it will kind of route. It will also have a replica, right? So if load balancer is, if it is not, so how would you identify it? So if it doesn't have a heartbeat, then that load balancer has failed, and you can have a replica of another load balancer, and then that can be used here. The secondary would become active, right? That is what block server goes down, then uh, other servers on its behalf can pick up the unfinished jobs. Okay, it's kind of doing the replication and stuff, something like that. A different region, then another region can do that, and yeah, metadata cache. Same thing. I think it's a master slave and replica mostly. Yeah. So notification service. Sorry, somebody was saying anything. Uh, according to Dropbox, 1 million connections per machine. Okay. Yeah, it's, I think in this entire thing they're talking about the replication and master slave.
So it's a synchronous replication or asynchronous.
Uh,
Depends on your requirement, right? If we are going for a strong consistency here, it should be synchronous. But if we want low latency and eventual consistency, then we can go with asynchronous.
hmm,
Yeah.
okay.
Like the major doubt I'm having is like whether to go for client side chunking or a server side chunking.
वो क्वेश्चन मेरा भी है मैं इस पे आज थोड़ा डीप डाइव करूंगा
Yeah.
नेक्स्ट सेशन वी कैन डिस्कस दिस
Yeah, there are some articles also here. So
आई रियली बिलीव क्लाइंट साइड चंकिंग इज अ बेटर way to do this to experience to improve user experience,
mm,
Yeah, I think if you are fine with a little overhead, client side chunking is better.
right? तो आई डोंट नो बुक में ऐसा क्यों किया है ब्लॉक सर्विस में चंकिंग हो रहा है बट पूरा फाइल
and
essentially
usually what I saw is, let's say when you are uploading any document, then it takes a lot of time, like maybe some time.
correct single thread will take a lot of time to like
And
save 10 GB
that it is, what I think is, it is taking time because it is kind of doing the processing where it is doing the chunking and stuff. So that is happening, I think, at the client side only. Then only it will, when it is divided into chunk, then it will send to server.
you're talking about your real life experience with Dropbox or
For example, I was uploading the video other day on YouTube, right? So it was a 1 hour video, and I was uploading it. So it was taking some time. It shows upload percentage, 10%, 5%, something like that. So
Mhm.
behind the scenes, it is doing some processing, right? Before
Correct.
it processes the video, it kind of optimizes it, compresses it, and then it will store. So everything is happening on the client side, but client doesn't store that data, right? It just make a network call to the server.
Yeah.
We can go through an engineering blog of any
Yeah,
thing.
implemented on different platform. It is error prone and lot of engineering effort. Centralized place block servers. Okay, they are saying that is implemented in block servers. They mentioned it actually here, if I'm not wrong.
It's all about trade-offs. So having the syncing part in a block server has pros of security and other things, but there are cons as well related to user experience. So yeah, we should have search for if any web engineering block is there for Google Drive or Dropbox or similar.
Yeah, and they're saying that encryption and everything is not ideal, so that is why they have kind of handled in on the server side,
Okay.
something like that.
So okay, there is a reference 6 point how we have scaled Dropbox. Let's we can discuss that.
Yeah, this is a YouTube video. Maybe we can
How
check.
we have to scale Dropbox. So okay, maybe they have talked about this in that video. So
Yeah, I'll just copy those and maybe I'll share with you guys so that nobody has to open this again. So another interesting. Okay, so I think we have done a good job. So thanks, guys.
yeah, good job.
Okay.